Today we will be factoring completely polynomials in all types of forms. We're going to jump right in with the examples, and we want to remember that the first thing we want to look for is the greatest common factor. The greatest common factor here for number 1 is 20, and then the greatest variable factor is x. So I'm going to remove 20x from each of those. And then I will divide 20x cubed by 20x. That gives me x squared. 220x squared divided by 20x will be 11x. And then 600x divided by 20x will be 30. Then I need to check this trinomial. Can I find factors of a times c that will give me a sum of b? I do expect you to show your work here. A times c would be 30. Sum of b would be negative 11. Right off, I think of negative 5 and negative 6. Those will multiply to give me 30, and they will add to give me 11. So I'll put 20x, and then I'll put x minus 5 times x minus 6. And we just factored that completely. Okay, now for the next example, the only common factor is m. So I'll take out m. When I divide m to the 5th by m, I get m to the 4th. Negative 81 divided by m is negative 81. Then this is a binomial. I do have a subtraction sign, and both of these are perfect squares. Remember, all even exponents are perfect squares. So I'm going to factor this as a difference of squares. I'm going to bring down my m, put two empty binomials. Oh, I think that's fine. Two empty binomials, put an addition sign in one and a subtraction sign in the other. I'm going to take the square root of m to the 4th. That's m squared. That goes in the first spot of each of these. I'm going to take the square root of 81. That's 9. That goes in the second spot of each of those. Then you want to check to make sure both your binomials are completely factored. This is an addition sign, so I am finished with this one, but this is a subtraction sign, so I need to check to see if these are perfect squares, and they are, so I need to continue. I need to factor that difference of squares, so I'm going to bring down my m squared plus 9, and then I'm going to write down two empty parentheses, one with an addition sign, one with a subtraction sign. I'm going to take the square root of m squared, that's m, and the square root of 9, that's 3. Then I should check one more time just to make sure. I have one subtraction sign, but neither of these are perfect squares. Therefore, this is the answer to number 2. Moving right along. Number 3, I don't have a common factor, but I do see that I have a sum, and all of these are perfect cubes. Therefore, I'm going to put an empty binomial, empty trinomial, and use SOAP. The sign of my original binomial and the sign of my new binomial are the same. The first sign in the trinomial is the opposite of that sign. and the last sign's always plus. Then I'm going to take the cube root of 27a cubed, that's 3a, and I'm going to take the cube root of 8b cubed, and that's 2b. Then in this spot, I'm going to square this, so that will be 9a squared. In this spot, I'm going to square this, so that will be 4b squared. And then in the center, to find this, you multiply these two. Ignore this sign, multiply these two. So 3a times 2b is 6ab. And that is my answer to number 3. On to number 4, I have 4 terms. They do all have a t to the third power, so I'm going to go ahead and take out greatest common factor of t to the third power. That would leave me with 5t to the third plus 2t to the second minus 5t to the fourth. No, not t to the fourth, so sorry. 5t squared, no, t to the first, minus 2. Okay, then I'm going to group, I'm going to put that in brackets just for now, so I can group with parentheses. I'm going to group the first two together. This is a case where you have to use grouping. Put a plus sign between those two pairs of parentheses. The negative sign should go with the 5. Then the first group here has t squared in common, so I'll factor out t squared. I'm left with 5t plus 2. The second group only has a negative 1 in common. I have a plus sign out there, but I'm going to go ahead and make it negative 1. And I do want to write the 1 just so you can see in just a moment. And then I'll have 5t plus 2. Then I always ask when I factor by grouping, did it work? Yes, it worked. Whoops, so sorry. It worked because these are the same. So to finish my problem, I'm going to bring down that t cubed. I'm going to put 2 empty binomials. I'm going to put what is the same, which is this, in this first binomial. 5t, whoops, no, I don't want that color. 5t plus 2. And then I am going to put what is different, which would be these that are out here. If you take away, imagine yourself erasing the green. What's left? T squared minus 1. Okay, now these are both binomials, so I need to check them. Are they done properly? Let's see. Or are they finished? Not necessarily done properly. Is this one finished? Yes, there's an addition sign. Is this one finished? Well, there's a subtraction sign. Both of these are perfect squares, so no, I'm not finished. I need to factor that one. Bring down my t cubed. Bring down my 5t plus 2. Put 2 empty binomials, one with an addition sign, one with a subtraction sign. Take the square root of t squared. That will be t. Take the square root of 1. That will be 1. And there is my answer. Okay, moving on to number 5. Finally, we're one that doesn't look quite so complicated. First thing I would ask myself about number 5, is it in the correct form? The answer would be yes. This exponent is half of this exponent. So I can go ahead and try to find factors of a times c, 1 times negative 48. That will give me a sum of negative 13. Right away, I think 16 times 3. I want my sum to be negative and my product to be negative, so one of these has to be negative. The bigger one has to be negative, so negative 16 times 3 is negative 48, and negative 16 plus 3 is negative 13. So then I'll put y to the fourth, remember always use your middle variable, y to the second in the first spot of these, I'll put minus 16, and I'll put plus 3. Then I have to check those binomials. Will this factor again? Hopefully you recognize right away it will. It factors into y plus 4 times y minus 4, and then that second binomial will not factor, so y squared plus 3. Okay, this next one over here, number 6, do I have a common factor? Yes, I do. They all have 5 in common. So I will take out that 5. I'll have p cubed plus p minus p squared minus 1. I'm going to put 5 in a bracket, and I am going to group p cubed and p together, put a plus sign, and group p squared minus 1 together. Okay, now, negative p squared minus 1. Now I am going to take out the greatest common factor, and then from the first group that would be p, and when you divide you get p squared plus 1. From the second group that would be negative 1, so that'd be p squared plus 1. Then to finish, I'm going to bring down my 5 and 2 empty binomials. I am going to put what they have in common in the first binomial. So that will be p squared plus 1. And then I will put what was different, the p and the minus 1, in the other binomial. I keep forgetting to change it. And am I finished? Do I have a difference of squares? No, I do not. So this is my answer. And I know some of you may be thinking, but Miss Bibb, yes you do. But I have to say, this is a sum of squares, and we haven't talked about how to factor these yet, but we will. Okay, continuing on to number 7. Let me see. I do have a common factor. 8, 10, and 160. What would they have in common? We know they have at least 10. I think that's it. So I'm going to divide them by 10. And that will give me 81k squared minus 16. That's a difference of squares. So then 10, 2 empty binomials, one with a plus sign, one with a minus sign. The square root of 81k, it's k to the 4th. Bet you were already thinking that. Glad I catch those little things. Apologize for making those mistakes to begin with, but we are all human. 81k to the 4th, the square root would be 9k squared. How that happened, I don't know. 9k squared. And then the square root of 16 is 4. And of course, I'm not finished. Can you tell which one of those isn't finished? Is it the first one or the second one? It would be the second one. I'm going to go to the very top, I think, and write the final answer. So I'll draw a line. I'm going to go up here and finish factoring. I'm going to bring up my 10, bring up 9k squared plus 4, and then I'm going to put 2 pairs of empty parentheses, one with a plus sign, one with a minus sign. I'm going to take the square root of 9k squared, that would be 3k. I'm going to take the square root of 4, and that would be 2. And I am out of time. I will do question 8 on my next video. Thank you for watching.